Hi there, I'm Dr. Heather Maddie, and in my last video, I talked about the impact data visualizations can have on health policy decisions related to COVID-19 and presented an example of a misleading bar graph and how to correct it. Today, I'll be showing you how to create the corrected bar graph in R. Let me share my screen and then we can go through some code together. And for this particular video, all of the materials I'm using are available on GitHub. It's in a public repository on my GitHub account. So my username is hmaddie. So if you search for my name and then the data visualization repository, you'll find it here. And all of the files that we're using to code today are contained in this folder. You can also go to github.com/hmaddie/data-visualization. So I've loaded up my R Markdown file here. And as a reminder, this is what the incorrect bar graph looks like. So for five counties in Georgia, we have the number of cases on different days in April and May. Different COVID-19 cases in April and May 2020. And it looks like from the graph that the number of cases is decreasing over time. But if you take a closer look at this graph, you'll notice that the x-axis is not in chronological order. So that's one major problem. Another major problem is that the bars are not in the same order across days. So taking some publicly available COVID-19 data, we are going to recreate this plot, but in the correct version to see that the number of cases is actually not decreasing over time, and we'll actually see a different pattern emerge. So for this particular plot, I've loaded the necessary packages I need. So that's readr, dplyr, ggplot2, and gridextra. And I am loading in a CSV file available on GitHub, and it's the New York Times COVID-19 data. So you can read this in using the public URL, and we can take a look at what this data set looks like. So it'll take a second to read in. I'm naming it US counties. So this data set contains the date that the number of COVID-19 cases were recorded, how many cases were recorded that day, how many deaths were recorded that day, the state, the US state this is corresponding to, and the county of that state. So for each day, starting in January, and for each county in the United States, we have the number of COVID-19 cases that were reported that day, and then the number of deaths. And these cases are cumulative, so they will, for example, for this particular county, on the 22nd of January, there's one case reported, and there was one case reported the day before, but this is cumulative. So this one case came from January 21st, and there were no additional cases on the 22nd since that number has not changed. So for our plot, we are actually only interested in 5 specific counties from Georgia: Cobb County, DeKalb, Fulton, Gwinnett, and Hall. So from this data set, I'm going to first filter out any rows that I don't need. So I don't need anything from any other states besides Georgia and those 5 counties. And I'm also going to filter out dates that I don't need. So these dates range from April 26th, I believe, or April 27th, we'll get there in a second, to May 9th. And so from this entire data set for the whole country, I'm going to filter out rows that I don't need and dates that I don't need. So to do that, now that I've read this in, I'm going to create a list of counties that I do want to include in my graph, and I'm just going to name that list counties. And then I'm going to create a new data frame. I'm going to call it Georgia counties. And to create that, I will take the US counties data frame that came from the New York Times data set that we just read in. I'm using the pipe, and I want to filter, oops, by state. So I only want Georgia, because I only want 5 counties in Georgia. And I want my county if it's in my list of counties that I've defined here. So one thing to note, the state column tells you which state that these records correspond to. So I only want to save Georgia. And then the county column is where the name of the county is listed. So I only want counties in Georgia. And then of those counties, I only want to keep the ones that show up in my counties list. So now I have filtered to the counties in the state that I want. Now I'm going to group by those counties. And what this will do is the next bit of code will arrange the data how I want for every single county. So if I arrange by date, that will put in chronological order the rows for each county. And then because these cases are cumulative, and I want to know the number of new cases on a specific day, I have to calculate that myself. So we're going to use a function called lag to help us do that. So I'm going to make a new column. So I use the mutate function. I'm going to call that new column new cases. And this is equal to the total cases, which are listed up here in this column, minus lag of cases. So minus the number of cases that were reported the day before. So it's cumulative. If yesterday there were a total of 10 cases and today that number is 12, there were 2 new cases added today. So what this lag function will do is tell you how many new cases there were on a specific day after subtracting the cases from the previous day. So sometimes that won't change, sometimes it'll be 0, but most of the time it will be positive, especially as we get later and later into the pandemic. So this will create a new column of new cases, and I'm just going to ungroup since I grouped these before. And now we can look at what this new data frame looks like. So I've called it Georgia counties. And once I do all of that, I can see that my dates are in order. The counties and states the counties are the ones that I want to focus on, the 5 that I want in my graph. They all come from Georgia, and then I still have all of the cases. And now I have a new column called new cases that shows the new cases for every single day. There will be missing values if there is not a day before that, and that'll be fine. Those will be ignored if we have any for our graph. The next thing to do, now that I've filtered out counties that I don't need and I just have the counties I want to focus on, is filtering out the dates that are not presented in our graph. So we're going to be doing a little bit more filtering. And so we're going to filter from and only keep the dates from April 26th to May 9th. So to do that, I'm going to take my Georgia counties data frame. and I want to save it. I'm going to create a new, I'm going to replace it with filtering out some rows. So using my original data frame, Georgia counties, and the pipe, I can now filter my date to be greater than or equal to April 26th, 2020, and my date will be less than or equal to May 9th, 2020. So what this does, I have a string here, that's why it's in quotation marks. To make our notice that this is actually a date, a calendar date, we use the function as.date. And so in our data frame, in the date column, if I say I want the date to be greater than or equal to April 26th of 2020, that will filter out any date that happens before April 26th. And by adding the next filter with date less than or equal to May 9th, that will get rid of any dates that happen after May 9th. So I've created a time interval where any dates before April 26th are disregarded, as well as any dates past May 9th. So I only have the days that are presented in that plot that I'm trying to recreate. So let's see if our code works. And we can use head again. And I've named it Georgia counties again. There we go. So it does look like it's working. Our first date is April 26th, and we can see the different counties that we're interested in, the number of cases, and then the number of new cases for each day. So this looks good. Now we are set up to create the corrected version of the plot. So to do this, I'm going to use ggplot and this Georgia counties data frame that we've created. So using Georgia counties and ggplot, I'm going to plot the date on the x-axis and the number of new cases on the y-axis. And I also want to show, have a different bar for each day for each county. So inside of our aesthetics mapping here, my x-axis is going to be date. It's a bar graph, and so I'm just going to designate my weight to be the new cases, so that the height of the bar will be the number of new cases for that day. And I want to color the bars different colors, one for each county. So I'm going to say fill equals county. With ggplot, we have a plus sign for the next layer. And so this is a bar graph. So the geometry I'm using is geom bar. And this is just a couple of aesthetic things to make your graph look cleaner and like the graph above, the original graph. And so the position is the position of the bars, and so it makes the bars sit next to each other. Next, if I put color equals black in quotation marks, this will make our bars easier to separate from each other because it puts a black outline around each of the bars. So we'll see that in a second when it's done. And finally, I'm going to be grouping by county, so I need to have another AES there. And the rest of it is more just aesthetics, and so I like to be as descriptive as possible with my visualizations. So here, for the title of my graph, it's going to match what was in the original plot. So this will be the top 5 counties with the greatest number of confirmed COVID-19 cases. On my x-axis, I actually don't want any, I don't want a label there. That's going to be the dates, and ggplot is going to output the month, year, and sorry, the month, day, and year. And if I don't put an empty string, you'll have the word date underneath those, and it's not really needed because we know that these are dates. So I'm basically just removing the x-axis label with this line of code. Then for the y-axis, I'm presenting the number of new cases. That's the height of my bars. And then I'm going to clean up the legend a little bit. So scale, fill, discrete. Oops. And I'll show you what this does in a second, but it basically gives a title to our legend and makes it look cleaner. And then finally, I'm going to make the x-axis look a bit cleaner as well by having the dates appear in different positions so they don't overlap with each other. And so we can do that with scale x date breaks. Using the same dates that we used above, so April 26th of 2020 to May 9th of 2020. So what this is doing, breaks are like your tick marks in your graph. And what I'm saying is seek is for sequence. So from April 26th to May 9th, I want each day, so I want to skip, I want each day to be represented on my graph. I want you to display the date for every day between the 26th of April and the 9th of May. So this will make it look cleaner, and you'll see all of the different dates. Sometimes ggplot won't show all of the different dates. So this will make sure that you get a date for every single day to display on your x-axis. A couple of other arguments for this. Date labels. This is a specific format, so I'm going to display them as the original plot did by day, month, and then year. And then this last bit is how I want my tick marks to show up. And so I'll show you what that looks like in a second and what that means. It's basically so they don't overlap each other. Okay, so let's that's the reason I've made it just a little bit too big. So let's replot this. Okay, that's easier to see. So when this actually prints out, let's do a happy medium. Let's see, figure width is equal to 7, maybe. Let's see what this looks like. Okay, so you can mess around with the width of it to spread it out or condense it, whatever makes it easier for you to see. But if I didn't want my labels to overlap, you can change the width of your figures up here in your code chunk. We could try 5, and that would give us a smaller width. It might be easier to see a little bit. So I've fixed the x-axis. That's the first thing to see. And what this guide axis n dot dodge equals 2 does, rather than having each date be on the same level across, sometimes, again, depending on the width of your figure, those labels will overlap. And so by using that command, I've kind of made them alternate in height, so they're not at risk of overlapping each other, even if the width is really small. So from this, we now have a corrected version of the plot because the x-axis is in chronological order and the bars are consistent throughout. And so Cobb County, with this kind of orange-red color, is plotted first for every single day. And so from this graph, now that we've corrected it to be in chronological order, we can see there is not a decreasing trend over time in COVID-19 cases. There's actually kind of a, different waves and different modes happening. And so at the time, states were considering reopening if the COVID-19 cases in certain areas were decreasing for 2 weeks. And so they plotted the 2 weeks above in a way that makes you think that the trend is decreasing over time, but these dates were not in order. And so this is very misleading and not good for public health policy decisions. And so if we make the corrected graph with, again, the axis in chronological order, you can see that there is not a decreasing trend over time. And so the state probably shouldn't have opened up at the time. It's a little bit jumbled, but you can pick out the individual county trends, and none of them seem to be going down or steady over time. They all seem to be kind of oscillating up and down. So this is what the corrected version of the graph would look like. ggplot in particular tends to plot things in chronological order by default, so that's really good. Most of what we worked on was filtering out to get the data that we needed to make the plot, and then making it look presentable with labels and titles. There's a title up here, and making our legend look good. So this is how you make the corrected version in R. I make a couple of other graphs if you want to check out all of the files available on the GitHub repository, and I hope you enjoyed this video. And so happy coding. Thanks for watching.